This call is now being recorded.
Yeah, you guys can see the screen, right? So these are the questions that we're gonna be doing. So I think, uh, yeah, as I said, I didn't put any hint to what approach you should use. So the certain questions can be solved using many approaches. It depends what type of a test is compatible with that question. So we're just gonna look. We look at the question, we inspect. The first question is, what can I do? Or ask yourself, can this approach work? Like for just an example, if you're gonna use integral test, can it work? You see, so you can apply that. Can comparison test work? Ask yourself that question. So yeah, I think those are some of questions we're gonna be asking ourselves. So let me just go back to yeah, question. Oh, we should start, right? I think the others will find out because we give them enough chance to join because they're not joining yet. So yeah, so I think we can begin now because we gave the others a chance to join. So they're gonna find us as they collaborate. Alright. Yeah, so here are the questions that we have, right? So we're gonna be solving them uh, one by one. So I'm also gonna yeah, let me just solve them here. So the first question that we have is let me see. The first question that we have is as follows. It's A. So this question that we have is the summation from n equals to 2 up until k of 2 over n squared minus n. So I want us to go back to the slides of yesterday. I want to show you something. And if you go back to the slide, we're gonna go to telescoping test, right? Telescoping test. So if we are on telescoping, is the alternative for it. Limit comparison. I think it's on somewhere up there. Yeah, yeah. I wanted to check something about telescoping. Right. So this question is this one. It goes to infinite. No, I shouldn't be going to infinite. I think that it's fine. Even if it goes to infinite. So I want to show you something, right? So if you have this question, yeah, I will check this question if they're really going to infinity or not. And the find out that infinity. Because most of them are not supposed to be going to, most of them are not going to infinity. They should be going to a certain value here. Let's say maybe it's going to n. So that at the end we can substitute n. So I will check that. So if you are on telescope and series, right? This question, here's how we're gonna do it. So this question goes to K. So since the question goes to K, we know once we expand it, we're going to have to say, let's say our question expanded, right? Let's say, if I plug T in the denominator, what if 2 over 4 minus 1 is minus 2? You see, right? Then I come again, next one I plug what? I would plug, let's say, I would say, this is I would say plus, then I say 2 over 3 squared minus 2, and I say plus over 2 over 4 squared is 3 minus 4. So if we check this, this would be uh, 2 over 2. This would be 2 over 9 minus 3 is 6. This would be 2 over 16 minus this would be 12. If I check this, there's no root pattern for us to check. This is 1 over 3, 1 over 6. So if I was going to say, let's say I divided it, I'd get 1 over 3. Then I divide 6 divided by 1 over 3. 1 over 6 divided by 1 over 3. Is it 1 over 2? Let me check. 1 over 6 divided by. Someone would say, let me try. The reason I'm writing this, someone would say, let me try geometric series, right? Maybe 1 over 6 is So 1 over 2. And then the next one here would be 2 over 5 squared minus 5. And the 5 squared minus 5 is 20. This would be 2 over 20. And the 2 over 20 is 1 over 10. Right? And if you take 1 over 10 divided by 1 over 6, this would be 3 over 5. So if you check, this does not lead up to geometric series. Avoid any type of those you see those series that we learned in high school. I want you to avoid those series. The only one that I want us to think of, strict series, right? So if you check, this does not satisfy geometric series. Okay, so this one it would be fine, right? Because you would take it out separate. But since these two don't match, now we're going to consider another test. So the test that we can consider, ask yourself, can I be able to factorize the denominator? You see, right? I should ask myself that question. Can I be able to factorize the denominator? The question should be, can I be able to factorize the denominator? You see, right? Let me, can I be able to factorize the denominator? That is the question that you should be asking yourself, right? Can you be able to factorize the denominator? You see, right? So that is the question I should be asking myself. And can we be able to factorize the denominator? Anyone? We can chat as I can. Remember, I can hear anything that you say. So maybe you can speak. I think I can hear you now. Uh, Dominic, can we be able to factorize the denominator? Mm. Can we be able to factorize this denominator? Yes, right. So we can factorize it. So we can factorize this denominator. Q and is equal to Q. Then we can have Q over N and minus 1. You see, right? So if the denominator can be factorized, this simply means we can apply partial fraction here. And if you can apply partial fraction on something, it means that you can apply telescoping theory. You see right now? So you can apply telescoping theory. First question, can I factorize it? Yes. Can I apply partial fraction? If you can factorize it, means that you can apply partial fraction, right? Given that the degree of the denominator is higher than the degree of the numerator, or it's equal to the degree of the numerator, right? And then, so this simply means we can apply partial fraction. So now let me apply partial fraction on that, all right? Then for me to apply partial fraction here, I'm going to say that partial fraction I'm going to take this inside on. Going to take 2 over n and minus 1, which this will be equal to a over n plus a over n minus 1, right? And this will be 2 is equal to, if I multiply both sides by this, it always multiply both sides by that. Here, the n will cancel the n will be left with n minus 1, plus a by n minus 1, plus c by n. This n minus 1 will cancel the n minus 1, right? And then, let me do this. Let me just show, right? So it means that I would come here and multiply by n minus 1. And so here, multiply by n minus 1. You see that? And that would simply mean that I would have 2 is equal to a n minus 1 plus b n. So this would multiply through. You see right? And with this, we will cancel this. See? Here, always, for you to find those factors of if n equals to something, you need to take this. You need to take this, if this, and minus 1 is equal to 0. You see right? That means that we're going to have n equals to 0 or n equals to 1. Right? So it means that we're going to use this. So this would mean if n is equal to, let's start with 0, then we're going to plug 0 wherever there's n. You see, right? And this would mean that a is equal to minus 1 over 2. No, not minus 1 over 2, minus 2. Because if I divide by -1, then I get minus 2. Then I have this first, right? Then I say now if n is equal to 1, right? I'll have 2 is equal to a0 plus b1. And then b would be equal to 2. You see, right? So now this would force us to go back and say, now this would mean that 2 over n and minus 1, this would imply that 2 minus this is equal to, there I had a over b, you over n, right? And a is minus 2 over n and plus 2 over n minus 1. And I should now rearrange this. 2 over n minus 1 minus 2 over n. So now I've rearranged this. I go back now and say this would now imply that the summation, you see, I think it started from 2, of this over 2 over n minus 1 would be equal to, now this would be the summation of n equals to 2 until k over 2 over n minus 1 minus 2 over n. So this should always be this minus something. Is that right? That is telescoping scope. That is the telescoping series. So now since I have this, now I can apply telescoping series. Right? Now I would say that this would imply summation of n equals to 2 up until k over 2 over n minus 1 minus 2 over n. Is that right? Then this would be equal to, if I plug the 2 there, let's check what do I get. I plug 2. If I plug the 2 there, I get 2 minus, if I plug the 2 here, minus 1. Then if I plug the 3, I get 2 over 2, which is 1, minus, I must keep plus here, I get 1, minus if I plug 3, it's 2 over 3, plus if I plug the 4, 4 minus 1, I get a 2 over 3. So don't forget, I said that we expand 3 times, right? Plus, if I get 4 there, then I'll get 1 over 2. Not plus, my minus 1 over 2. That is minus 1 over 2. You see, right? So this would be plus 2 to the dot. You see? And then plus. Then now, I do the last 3. Also, the last part should either be 3 or something, right? But this is how you check. How do I apply this? This is what n minus 1, right? And this is n. Usually we take the opposite of this. Now since this is n, we don't know what the opposite of n is, right? So we can try to count two steps back from this. You see, what are those 2 steps back? N minus 2, n minus 3. So we can start with n minus 3. You see, right? So we can say, now we can have this. This is 2 over, now don't forget we are plugging this k, right? We say, then we say this, we say instead of K, we can call it plug N equals to 5. But if it's ending at K, that would plug K. But if it was ending at infinity, it's like S. So I'll write that on the next slide. Then here, so with K, I don't want us to be changing things later, right? So we're gonna say K minus. If I apply K minus 2 here, K minus 2 minus 1 will be K minus 3, right? And then minus, and this will be 2 over K minus 2 plus. So now I move from K minus 2 to K minus 1. And this would be 2 over K minus 1 minus, let me do this. I thought that we are plugging 3 steps, right? I plug the 2 steps back. 3 steps back. Let me write it here for a second. 3 steps back will be N minus being 1 step back. 2 steps back. Let me see. Yeah, we're plugging from N minus, correct? This would be minus 3 to be K minus 4 minus 4 minus K minus 3. The reason why I want us to plug 2 steps back is because I want us to see if the other ones are going to cancel or not. 2 over. Now it was 3, now it's plus 2 there, plus K minus 3. Plus, I wanted to see if these are going to cancel. So I'll show you again how do we check that. And this is minus 2 over K minus 2 plus, then now we go back to K minus 1, and this will be 2 over K minus 2 minus 2 over K minus 1, and then we come back to K. And this would be 2 over K minus 1 minus 2 over K. Yeah. So let's check this. We did 3 times, right? We plug the 3 times. Then we check. I said that, and also I said that you check this one if they're going to cancel first, right? And we check also if this one is going to cancel. So this cancel with this, and this cancel with that, right? So we're interested in those ones. So, or I can say this because already we know that this one. So to summarize things, I can also say we should check if these two can cancel, right? And then for bonus, we check if this can cancel it. But usually this one cancels with this one, right? But if it doesn't cancel, it's fine. So we can check if these three can cancel, right? 1, 2, 3. So this will cancel with this, and this one cancels with this. So already the 4 of them cancelled. I know that this will cancel. This is right. So from there, I can say this. I can say from the back, whatever that cancels here, I should check if it cancels after here. This is right. So let's start. 2 is gonna map with the last one. 1 is gonna map with the second last one. The third one is gonna map with the last third one. This is right. The first one will merge with the last first one. The fifth one will merge with the last fifth one. This is right. So I can merge them like last time. I merge them with different terms. I can still do that. This is right. Then we know already. You know which one merges with which one. This is right. Those are the ones that will cancel. So even here they should cancel. So now we say this. Let me check if this one cancels. This 2 didn't cancel, right? It merges with this one. So it means that also here this one cancels. You see? And then the 1 cancels. This means that it cancelled as you see. And then this one also cancelled, which is this cancelled. And then this cancelled, which merges with this one. It should also cancel this one, right? It's cancelled with this one. So this one also cancelled, which merges with this one. So I didn't check this 1 over 2, but if you check this side, it's cancelling. this would measure the 1/2. So it means that from going forward, everything will cancel. You see, already we are certain of that. So now we see even this will cancel. You see that? We see that everything else is going to cancel. So here, we'd be left with this. We'd be left with 2k. We're left with 2 minus 2 over k. You see? And this is our f of k. So I won't call it f of n anymore because they changed our value to k. You see, right? So now this would imply that the limit as k approaches infinity of f of k would be the limit as k approaches infinity over 2 minus 3 over k. Right? And this would be 2. So we see that this converges and it converges to the limit 2. So if we go back, now let's go back to those infinite series. Right? Yeah. So if we go back, this one was ending at infinity, right? So that's why I had to substitute the n which we're dealing with. I substituted n. Is that right? And I was measuring them. I was like, this will measure the second one, because it's the second one. Is that right? And this will measure the second, third one. This would measure this. This would measure, and this one would measure this one. So even though I didn't cancel this, I won't take it because I know that it's going to cancel. Is that right? So this one, the first one didn't cancel 1/2. Also, the last one will cancel because they're big. Is that right? And the reason why you see, I said it. The reason why I didn't use k here is because this one ends at infinity, it doesn't end at k. So if it was ending at m, I was gonna substitute m here. So these are the certain tricks that they're gonna be using. Right? So you should keep note of that. So if you go to the second one, let's say I use f of n, reason being, and I said n approaches infinity because we're dealing with n. Okay, right? But if it was another variable, say that variable approaches infinity of f of that variable. So if you come to the second one, also this one, it's approaching, it's going to infinity, it's up until infinity, right? So it means that by partial fraction, I would use the n, and partial fraction is fine, I would use n, this is fine. Okay. And when I come here, when I expand, I would expand it using n, because it ends at infinity. And here I even showed, I was like, this one measured to this one. If I said by arrows, and I was like, the second one measured to the last second one. You see? The third one measures with the last third one. And if you check, this one didn't cancel. You see? So it means that this one is not supposed to cancel out. That's why I have it here. And this. You see, right? That's why I have this. You see them, right? Here they are. So you should always try to take that format. Which one didn't cancel, which one cancel. And then, yeah, I think I only covered two examples, right? So now let's go to the second one. The second one, we can say that sorry, converges the limit to. So now if you check the second one already is in this format. This minus this. You say right, this minus this. So we can easily apply telescope in there and it ends at K. So I can now come and choose the second one. So let me write to the second one. It's B. B has the summation of N from 1 up until 2 of sine of 1 over N minus 10 of 1 over N plus 1. Right. So this one, if we expand it, we don't have to apply a partial fraction, right? If you expand it, if right, sine of 1 over 1 would be sine of 1 minus sine of 1 over 2. I'm not going to simplify that. All right. Plus, I'm going to expand 3 times. Don't forget sine of 2 minus sine of 1 over 3 plus sine of 3
Dokotela.
minus sine of 1 over 4. You see, right? So I've expanded them.
Dokotela.
That means that now I'm going to do this. Now I'm going to dot plus. Can I check this? This is n minus your n plus 1. So I'm going to take the opposite, which is n minus 1, and start plugging here until I get to n, right? So this would be sine of 1 over n minus 1 minus sine of, I put n minus
Sir.
1 get 1
Sir.
over n.
Sir.
Okay, right? So I have plus. Now we check. So now we first we plugged n minus 1, right? Now if we move to the second one, n minus 1, we have n. If you increase the n, so now I plug n. So if I plug n, I'm going to get sine of, I'm going to get what I have. Then I'll change this according to this variable, right? I'll have sine of 1 over n minus sine of 1 over n plus 1. But check, they say that where you are doing, to k. So move the right hand easily come here and change and write k. Is right? K, K, K. Now this satisfies the condition. That's right. So that one, as long as it satisfies the condition, then we are good to go. So now we need to check which one cancels, which one doesn't cancel. You can tell me here which one will cancel, which one will cancel. I forgot something. This one is 1 over 2, right? So it's 1 over n. Which one was plugged into? This one is 1 over 3. It's 1 over 1 over. So now once check which one will cancel, which one will cancel. So this will cancel with this cancels with this. So as long as this one cancels, right? 1, 2, 3, 4. You're good to go. Right. So if you expanded 3 times, I just want you to focus on 1, 2, 3, 4. If they're going to cancel. You say right. So let me even put the motor red arrow. If these are going to cancel, then we're good to go. We don't even care about this one, right? So but I have to cancel that it's canceling. Then I'll go back and match. I want to see this one matches with this one. It doesn't cancel, right? This one matches with the second one. Cancel. This one matches with this one. It cancels. And this one matches with this one. It cancels. You see? So now I'm going to say this will be equal to, but let me cancel this, right? And the cancel. This one cancelled, the red one cancelled, the green one cancelled, the blue one cancelled. This one cancelled, so I have to show them there. Then I leave the ones which didn't cancel. Sine of 1 minus sine of 1 over k plus 1. You see, right? Then I have that. So if I have this, I now know that this is f of k is because so what I'm doing here, right, is called the partial sum. You see, right? The partial sum. So let's all call it f of k or f of n. It depends on what variable you're dealing with. So this is minus one minus just in case they tell you to find the partial sum, you can ask any question. Then this will be a find the limit now. So k approaches infinity. F of k is equals and also something. Let me show you something here. You see this? I said that k approaches infinity. So this is the same as f of infinity. You see, right? This is the same as this. I'll highlight this. And then if we go back here, this will be the limit. So k approaches infinity. That's fine. That's one minus 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 k plus one. You see, right? And then this will be f of infinity will be equal to, and then this will be the limit, not the limit. If I apply the limit on this, I'll get fine. That's one. There's no need for us to show all the calculation here, right? This one will be zero. So I'll have sin of one. So that is the solution there. You can leave it as it is, right? Any question? Question before we go to the third one? So no question, right? All right. So now let's say this. We come to see. Now we say to see we have the summation. This summation is n equals to 1 up until infinity. So 5 over pi to the n. You can tell me what are we supposed to do here? Anyone? When you look at this question, what do you see? What can you say? What can you do? What approach can you think of? Anyone to give it a try? It's good not to try. So you can gain some confidence in going to that moment. I know this one. Anyone?
I think we are going to use a root test.
You guys don't want to try anything. You guys want a context try. Here you don't try. Context try I pick you, but it's fine. So next week we're gonna be having context. So we have this also. Let me check if the attendance is.
Nice. No, it's because I'm using the PC's mic, right? I always use the PC's mic, so it's not muted. I thought you guys would hear me from the PC. I'm just shocked. Yeah. If you can hear me, let me see something. Yeah, since I was using the PC's mic, I thought maybe you guys could hear me, né? But let me see. I don't know why. Yeah, you guys will just watch the recording, no problem. I thought I'll share the recording. I thought everything was clear and loud, you see. But it's fine. So this, I think it's this web browser. It betrayed me. The mic is on the other side. But now you can hear me, right? All right. Yeah. It was from the PC. I think the problem was with the PC beside. Maybe it's the network or something. So yeah, I think maybe we can stop here. And I'll maybe if it's also not loud on the recording, I'll record while I'm explaining those examples, and then I share the recording because I thought everything was clear. Yes, the PC. So